We are going to look at inversions of permutations. Let sigma be a permutation of the set 1 up to n. We say that the pair ij is an inversion of sigma if I is less than j and sigma I is greater than sigma j. For example, the identity permutation has no inversion. And if sigma is this permutation, then the pair 1, 2 is an inversion because 1 is less than 2, but sigma 1 is 3, which is bigger than sigma 2, which is 1. And there is another inversion here. If I look at the pair 1, 3, sigma 1 is 3 and sigma 3 is 2. So sigma 1 is bigger than sigma 3. So 1, 3 is also an inversion. And that's all. There's no other inversion. For example, if you look at the pair 2, 3, sigma 2 is 1, which is less than sigma 3. So that's not an inversion. Now, the total number of inversions is denoted by the pound sign inv of sigma. So in this example here, the total number of inversions is going to be 2. Now we're going to look at a very special permutation. And the permutation basically swaps only 2 elements. So you have 2 indices ij, and sigma I is j, and sigma j is I. And for all the other indices, k, sigma k is k. And so it looks kind of like this. And you see here, I gets mapped to j and j gets mapped to I. And we want to count how many inversions there are. First of all, there are no inversions involving these elements. And there are also no inversions involving these elements. ij is obviously an inversion. But if we look at the pair ik, where k is between I plus 1 up to j minus 1, so I'm looking at pairs like this, then it gives an inversion because j is bigger than any of these here. So this is an inversion since sigma I is equal to j, and that's bigger than k, which is sigma k, when k is from 1 plus I to j minus 1. And if we look at the pair k comma j, where k again goes from I plus 1 to j minus 1, so I'm looking at these elements compared with I. And that's going to be an inversion because every such element is bigger than I. And so what we can say about the total number of inversions of sigma is going to be, so ij is an inversion, so there's 1 inversion. And then for each value k from I plus 1 to j minus 1, I get 2 inversions, one of this form and one of this form. So this is 2 times j minus 1 minus I plus 1 plus 1. And if you simplify this, you'll get 1 plus 2j minus I minus 1, which is 2 times j minus I minus 1. And this number is always odd.